We're going to continue with that today. I hope we still remember the laws of logarithm. Perhaps I show you a review of what we did last time. So you can also open your notes and let us look at the review of what we did together. Please mute yourself, everybody. Someone is being noisy here. Thank you. Last time was Monday. That will be 30th. Let's see, Monday 30th from 4. Okay, this is not from 4. From 4 was before from 5, I think. I should have renamed my folder. I think I have it. Got it. Okay, so I'm sharing that with you so we can review that. So this was what we did the last time. Can everybody see the board? All right. So the first law, it's about adding logarithms on both with the same base. It means you have to multiply the numbers. The second is about subtraction, so you divide. When you add or when you subtract, there are two logs, but the result becomes one single log. So be careful with that, okay? Logarithm of a number to the same base is 1. If you have logarithm of a number in index form, the power at the back, the power could multiply the log. So the power looks like it comes back. Logarithm of 1 to any base is 0. If you have a number in logarithmic form, you can change to index form. We will apply all this later today. We did change of base. So if you want to change the base of the logarithm, so you write it as a fraction in the new base, then you write the number the way it appears, a first, then x next. And with this, we're able to see what the reciprocal of a log looks like. If you are looking for the reciprocal of a log, it's just the same as interchanging. So this is a reciprocal. It just interchanges. And the last law that we looked at is that if you have a number in index form, but the power happens to be a logarithm in the same base of the number, this log and this number cancel, leaving behind whatever you have left in the log. Please note that there is no number at the back here. So if you have any number at the back here, it has to go forward first using this property 4. So we will apply this using some simple questions today, and we will also continue next time. So from next week, just for the records, I have decided to add one more class to our class. So there's no issue of I need time for IGCSE anymore, since no IGCSE is happening anymore. So we might as well do our maths more, okay, while preparing for our IB. I've also prepared a worksheet, and I'm still preparing the worksheet. Just a sec. It's part of the worksheet I use for the IB class. So I'm adding more, and all these are from IB past papers. I'll share with you, but I'm adding some simple ones first before you consider that. Anyway, we can begin today with this first question in the IB past papers. Okay, can everybody see that? Just nod if you can see what I'm showing you. Can you see what I'm showing you, the Word document?
Yeah, we can see it.
Okay,
yes.
good. Okay, so we're going to begin by looking at this IB past paper, the few ones that are still easy to use the first few laws to do. So let's get right to it. Just a sec. All right, let's get right to it. So logarithms. It's 1st of April. Happy New Month, everybody. Our stay today is more of practice, example and practices. Okay, get right to it. So the first question from this IB past papers looks like this. So simplify or evaluate. We're not solving the equation yet. So we are either trying to simplify or evaluate. Evaluate means get a number out of this. So I can say something like evaluate x squared if x is equal to 5. Does that make sense? So you get a number, okay? But I can also, this is simplify. Simplify, maybe x squared divided by xy. Here you don't get a number, just reduce it further. Does it make sense, everybody? Okay, so simplify or evaluate is what this section will be about. We can either simplify the logarithm or we can evaluate it to get a number. All right. Let's see the first question that is in that worksheet that I'm preparing from IB papers. It says simply log 3 log 36 to base 6. You may start looking at it. Then when I'm done copying the questions, then I will solve it. Then the second is log to base 6, 4 plus log to base 6, 9. Please note that all the activities we are doing today, no calculator is needed, so no one is expected to press their calculator. Mr. Ironman, you don't look like you're doing anything. You just look like you're lounging on your couch. Hello. Carter, can you hear me?
Yep.
You don't look like you're writing. You look like you're just lounging on your couch.
Oh, okay. I need to grab my notebook then.
What? So what exactly did you come for? To inspect everybody?
No.
So why didn't you get your notebook before sitting down?
Because I had computer science class before.
It doesn't matter. You came earlier than everybody.
Yes, I did.
Come on, take this thing seriously. So these three are from IB papers, like I said.
Mr. Daniel,
Yeah?
I'm not sure what we're supposed to be doing. Are we supposed to solve it or change the base?
I don't understand. It says simplify. Did you hear me when I mentioned simplify and evaluate? I wrote it somewhere here. Were you listening?
I don't get that part.
Were you listening when I did something here?
Yes.
Okay. I'll do it again.
Thank you.
So simplify or evaluate. When they ask you to evaluate, it means you get a number as your answer. And I give an example. I can say evaluate x squared when x is equal to 5. It means you must get a number as the answer. And I'm sure everybody knows the answer is 25. On simplify, you can be asked to simplify this expression. The best you can do is to write it as x over y. You have just simplified. For this question, every question we are doing today is about either simplify or evaluate. So, and that's all I've told everybody. Thank you.
Thank you.
do it one at a time, quickly. These are still simple parts of IB papers. So we start with the simple questions first. Okay, let's do the first one together first. What did anybody get for number 1A? Can I hear you, please?
I got 2.
2. Anyone else? Did you get 2 for 1A?
Yes.
Yeah, so let's see how to work that out. So so that you're certain you did the right thing and you worked the right steps. So this is about the law. You are using 2 different laws here. One of them is the law that says if you have this B can come to the back, right? Then you have B times log that, right? That's the first law you are going to use. So we're going to write this as log to base 6 squared. Then when you apply the law, it means 2 times log to base, isn't it? And there's a law that says logarithm of a number to the same base is 1. So this simply means 2 times 1, and that is why the answer is 2. If you do not show how you have applied these 2 laws, you have not done anything meaningful as far as I'm concerned.
I used a different way.
Can I know the different method, please? What different method did you use?
I used rule 6.
Row 6. Let me see what rule that is. Oh no, did I just close that thing? I shouldn't have closed it. What does row 6 say, Justin?
It says if log base x a equals b, then a equals x to the power of b.
Okay. So basically, this is what Justin has done. This is how we did question 1, but you don't need to use that. This is better. We use that when you can't easily convert this to this base. Okay, so this is what he has done. He has assumed the answer is some y. Am I right, Justin?
Yes.
Then it used that law to get that is 6 equals 6 to power y. 6 squared equals 6 to power y is equal to 2. So this answer must have been 2, just like we got here. Am I right? Is that what you did, Justin?
Yes.
But this is too long. This is easier. We use that. I will give some examples now when we can't use this easily. I think this one is, the second one is easier as well. Log to base 6, 4 times 9. Log to base 6, 36. And that is 2. You know why I just wrote 2 directly? Because it's the same exam paper. This has been done already and you got 2. So since I come across it again, I just need to copy the answer. Okay, but if it is a different question, I have to follow this green step. Does that make sense, everybody?
Yes.
Yes.
All right. Okay. So on the third one, log base 6, 2 divided by 12. Who has done the third one?
Me.
Kelly. So what did you get?
I get -1.
That's
Negative.
correct. That's correct. So again, I'm using the law. So you see, -1 multiplies log 6 base 6. So that will be -1 times 1, which is -1. Okay, let's see, before I put another set of IB papers, I'm going to put more of these 3 laws that have been used so far, or 4 laws that have been used so far. We have used addition, we have used subtraction, we have used the law that allows the index to come backward, where I use logarithm of a number to the same base is 1. So we have applied 4 different laws in this question so far. So I'm going to write something similar to just to make sure you use this now. Okay?
Okay.
All right. So let's attempt this. Five minutes maximum. No decimals, fractions only where applicable. Are you done?
I'm doing the last question.
Okay. Kali, are you done?
I'm not done.
Okay. Who's ready? Raise your hand. Alex, I thought I said no calculator. So what exactly are you checking?
I'm checking question C.
Question C.
C.
Why?
Yeah, I'm trying to get the square root 125 to different value.
Why?
Because right now I don't know how to convert that into like
So you know how to write square root of 25 in terms of 5?
yeah, I'm trying to do it.
Okay. Joey, are you ready?
No, I'm stuck on a point.
Which question is that?
It's like it's actually B and D, but like for both questions I got up until a point and I couldn't continue solving.
Okay, B will be a different case, D will be a different case. Anyway, so let's do the correction, then I'll put another set of questions, then that will guide you. So everybody, please pay attention. The first one is easy. So you must have written base 3, then 3 raised to power 3, right? Then 3 times log 3 base 3, which is just 3 times 1, and that is 3. So that's the end of that. For this, the first thing you must have done is to write it as a single log and divide 3 out of 24. Is that what we did?
Yes.
Yeah.
Yep.
So this must have been log to base 2 of 1 over 8. The goal is now to write it as log to base 2, 2 raised to power something. But this must remain your 1 over 8. Okay? Because if you're able to write it this way, then this box can come backward next. So, and how do we do that? So we say log to base 2, 1 over 2 cubed. So, which is why I don't know why Alex is pressing a calculator, because no calculator can tell you what you are about to do. So you get log to base 2, 2 to power minus 3. I'm sure we remember that in indices, 1 over a to power n is a to power minus n. Do we remember this?
Yes.
Yes.
So now negative 3 come backward. Joey, I believe you have seen what is missing. Then this is minus b times 1. Is there any mistake?
I just want to ask, is it okay to directly write the 2 to the power of negative 3?
Exactly. From here, it's okay to directly write it here. That's okay. I just showed the next step just for anyone who might be confused. Okay?
Okay, thank you.
All right. Does this make sense, Alex?
Actually, I have a question on C, not B. I managed to finish B just now.
Good. All right. So let's do this then. So this is log to base 2, not to base 5. Log to base 5. Now, at first, I'm going to write 125 to power what? Melody. To power what melody?
Negative 5. Wait, no.
125 to power what? I'm talking about what's the power that I'm supposed to write next.
2.
So are you saying 5 to this is the same as this?
No.
So
Is it a fraction?
yeah, it's a fraction. What fraction?
1 over 2.
Exactly, 1 over 2. So you guys need to remember indices. In indices, the nth root of a is a to power 1 over n. Okay, so you need to remember this. So square root will be 1 over 2. Cube root will be 1 over 3. Fourth root will be 1 over 4. Okay, so now that's that. But then this is not 5 yet, but I need 5. So I'm going to write it as log to base 5. Whatever this is, raised to power 1 over 2, right? Could I have everyone's attention? Okay.
Yep.
So what do I have inside the bracket?
5q.
5 to the power 3.
Good. So now remember also there's a law in indices that we have learned that, so I'm putting all this reminder here. If I have a to power m and there's a bracket and I have a to power n, what do I get?
A to the power of mn.
Good, which is a product, isn't it? So this will be log to power 5, log to base 5, 5, 3 over 2. Am I right? And we can apply
Yeah.
it. So you see, before I could apply the law that enables the power to come to the back and multiply the log, I make sure I have the same thing here and here. None of them is negative, none of them is of different sign. So I'm not having 5 here minus 5 here, minus 5 here, 5 here. It has to be exactly the same. They have to be identical twins, sort of. So this is 3 over 2 times 1, and that is 3 over 2. Now the last but not the least. Now this last one, I intentionally included this question. You will agree with me that while it is easier, please look up everybody, while it is easier to express 1 over 8 as a power of 2, to express 27 as a power of 3, to express 125 regardless of square root or cube root or whatever problem it has as a power of 5, it is not easy to express 81 as a power of 27. Okay? It is easy to express 64 as a power of 2, 16 as a power of 4, but it's not easy to express 16 as a power of 8. Does it make sense? Aha. So if we have cases where you don't have something that can be easily done, you apply what Justin did in question 1A. So we're now going to use law 6 in this question. Because we don't know what it is, let it be some variable x. Because we don't know what the answer is, let the answer we will eventually get be some variable x. Then you apply, is that law 6 again? So this will be 1 over 81, 27 to power x. Okay? So 1 over 8 now, 81 and 27 can be expressed as a power of what?
3.
3. So you take both of them to power 3. So Justin, you can write 3 to power minus 4 directly, but for the sake of others and anyone who needs systematic approach, I'll write it this way first. Okay. Now, from here, so this now becomes 3 to power negative 4. This becomes 3 to power 3x, which means negative 4 equals 3x, which means x is equal to negative 4 over 3. And that is the answer. Does that make sense, please?
Yes.
Yes.
So let's look at the corrections, and I will give something similar on this now. So again, I only want to see this step when it is not easy to express one as a power of the other. Okay, in cases where I give you log 125 and this is 5, it's not easy to express it. Do you agree? But of course, we cannot say this 5 is actually the cube root of 125. So then you can do it. You see it? Okay? Do you agree? 5 is the same as this. So I can work this out also this either way. But whenever you have a problem where it is not easy to do, please use this method. Whenever you can express it directly, use the other method. Or should I just say use method that is convenient but not too long? All right. So this is not a time for us to show off that, oh, I know this step and this method. This is a time for us to use which method is easier to do, more reasonable, more efficient, and less time consuming. Okay. So take note of these corrections, please, while I move to the next one. Can I move to the next page? Elson? Elsin? Elsin, hear me?
Yes.
Could you take a screenshot and send to the group so I can move to the next page? Let me know when you've done that so I can move on.
Okay.
Can I move on to the next page? Just tell me when you have taken the screenshot, not when you send it to the group.
Oh, okay.
Have you taken the screenshot?
Yes.
All right, so I move on. So please send to the group when you're done doing whatever you're doing on your computer.
Mr. Daniel, my
Yes.
phone ran out of battery.
Uh-oh. So your camera will be gone for now?
Yes.
Okay, I will understand.
Thank you.
You're welcome, sir. So question 3. Is Charlene in this class? I haven't heard anything from her today. Hey, quiet friend. Where is she? Wave your hand or say something if you're here. Oh, okay, there she is. You have to say something, miss. Okay? All right, so let's move on. Let's have, okay, thank you, sir. Thank you, sir. We appreciate you. Thank you, thank you, thank you. Thank you, thank you, thank you. All right, so let's move on. 3a. Log to base 2. And this is also an IB question. Yes. 40 minus log to base 2, 5. So start with that. Okay. Okay. Let's Do not begin question 4, even if you are done with the rest. Are you done with question 3?
I'm on D.
Okay,
I'm
good.
on D2.
Good. All right, let's take 2 more minutes. Let's work as fast as we can. Are we done?
I'm on E.
Okay. Okay, another 2 more minutes. This is the last 2 more minutes. Kelly, everything good? Is it that your camera is frozen or you are showing me a picture on your phone to pretend I'm watching you live? Okay, I can see you now. Everything good?
Yeah, everything's good.
Okay. Hansen seeming not to have my time today. She's just minding her business.
I am stuck on E.
All right, that's fine. We are all stuck at
I'm
something
stuck
at some
on
point.
two. It's so hard.
I'm also stuck on C on E.
I don't know how to E.
Okay, wait, let me see what I put there. Oh, and it's a very sweet question. Very sweet. All right, let's do it together. Let's see how sweet the question is. Are you ready? Are you? Nice of you
Aye, Captain.
today. My go-to noodles guy. Dude, you still owe me some noodles. Even if we come back to school in 3 years' time, I'm gonna get my noodles from you. All right, so let's do this. Let's do this. Okay, so just for the sake of everyone, and for those of us that might still have 1 or 2 challenges with this, I'm going to go through with everything again. Okay, so the first one I combine as a single log by dividing, and I get log 8 to base 2, which I can simplify as log 2 cubed to base 2, which is 3 log 2 to base 2, and that is 3 times 1, which is 3. Who got that? Raise your hand if you got that.
I'm raising my hand.
Okay, good. You see, this Elson guy likes to show off that he's a techie guy. He didn't raise his hand. He used the emoji. Show off, man. All right, good. So the next one is also easy. Okay, now someone is trying to copy what Elson is doing. Copyright. Okay, so this will be log. That's enough, dude. Log to base 25 of 1/5. Yeah. And clearly, I can write this as 5 to power something, but I can't write it as 25. So I might be stuck. Of course, there might be ways you can manipulate that, but it will be too difficult. So in that case, I can say the answer is y. So if the answer is y, then I turn it into equation problem, which means I have 0.2 and I have 25 to power y. So while my 0.2 is 1/5, this will be 5 to power 2y. So this is 5 to power -1, this is 5 to power 2y. And in that case, I get green. Then I get 2y is equal to -1. Then the result will be -1/2. Who got that? Raise your hand if you got that. Okay, everyone is using the techie now. Good. All right. Okay, so let's go to the next one. Wonderful, wonderful, wonderful. So to the next one. Okay, yellow, I found yellow. Now, I could have written this, I could write this as this, then 3 to power 1/2, but it's not looking promising if I need to write it this way. Okay? Although there's a way, I'll show you. If I take this first, uh-oh, my Form 5 are trying to join. I'm going to let one of them join, and she's going to run away. So you can have that, right? Then I could change this 3 to 9 by writing it as 9 raised to power half. Can you see that? Then I take the half backward again. So I have half, another half, I have log 9. Can you see? And I get 1/4. Does that make sense? So I could do that, but it's too long a process. So instead of doing that, so what I would do is to just use that method of changing it into equation. So I don't want to have to do 2 different things. So I'm just going to change it to equation. So I say this is A. Okay, A might look like 9. I say this is B. So then I can change it to index form. So we call this logarithmic form. Logarithmic form. Okay, this equation is in logarithmic form. That is, the equation is in form of logarithm. So I will now change it to the index form. So square root of 3 is 9 raised to power b. So this is the index form. So 3 to power half on the first side is 3 to power half. On the second side is 3 to power 2b. Okay? Then I have 1 over 2 equals 2b, which means b is 1 over 2 divided by 2, which is 1 over 2 times 1 over 2. So b is 1 over 4. So we got the same 1 over 4. Okay? Same 1 over 4. Just a sec. Hi, Verna. Sorry, I joined your class soon, but you're welcome to stay here if you want. All right, so for this is so complicated, right? Square root, cube root, so messy. So we're not going to waste time. So let it be C, for example. Again, this is the logarithmic form. Then we change it to index form. Now, guys, please listen. This is an expression, not an equation. This is an expression, not an equation. Okay? So now this is an equation. Everything here is an equation. So if you have an expression, you're supposed to just continue to simplify until you get a number. If you have an equation, you're supposed to have equal side, true side with equality in between. Okay? So we have decided to turn this problem that is an expression into an equation. Does that make sense? Anyway, so I'm going to be having the cube root of 49 to be equal to the square root of 7 to power c. So this becomes, that's the meaning of that. It says this implies 49 to power 1/3. This implies 7 to power half, then to power c. So everything becomes 7 to power 2 to power 1/3. This is okay now. This is half c, or just c over 2. So while this is 7, Crystal, okay, not Crystal from this class. I'm going to let her in too. So while this is 7 to power 2/3, this is 7 to power c over 2. Okay, I don't have enough space, so I'm just going to squeeze it in here. So now I'm left with 2 over 3 equals c over 2. Agree? So which is 3c equals 4. Then c equals 4 over 3. Does that make sense? Okay? So that's that. Now, the main one that everyone seems to get confused with, that's okay. Again, this is complicated problem. So let it be some r. Okay, my r looks weird. Okay, that looks better. Okay, so again, this is the logarithmic form. Let's change it to index form. We change it to index form, 0.08. Oh my God, my form 5 are bombarding this class. We just let them in so they can have fun while I'm getting ready. Welcome, form 5. So this is going to be 8 over 1 over 125. Do we agree? Because it's 8 divided by, oh, that's why. I'm sorry, that's why you couldn't figure it out. This should be 3 zeros, 2 zeros before 8. I think that's why you had issues with it.
Yeah,
Okay.
we got 2 out of 25 with 0.08.
Can you do it now?
We can't do it.
Okay, all right. So with this now, you can go ahead, right? You can
Yes.
go ahead. Okay. Okay, so before we stop in the next 4 minutes, with form 5s that are in now. Hi guys, just hold on. I'll join you soon. You can stay or you can go. It's up to you. So before I go to the form 5, I still have about a few minutes with you guys. So please look at this last set of questions, because when I send you something to try, you're going to make use of this, okay? So please look up. Look up, everybody. Now, this last set of questions, normally, I need you to be sincere now, normally, what would you be tempted to say normally if I ask you, what is log 27 divided by log 3? What would you be tempted to say?
Log 9.
Log 9. But of course, that's too good to be true, yeah? Can you press your calculator? Log 27 at the top, log 3 at the bottom. See if you get log 9. Remember, log 9 is not 3. Log 9 is meant to be some decimals. As a matter of fact, log 3 is 4771 times 2. That should be 0.
I got 3.
You got 3. Now check log 9. Is that 0.9 something?
Yes.
Yes.
And they're not the same, are they? So there's a
No.
All right. So what is the disconnect? Let's look at it. So when you have a situation like this, you apply this same law we've been using today. So write them as log of the same number. Form 5, you're welcome to stay. I'll close the meeting soon, but you're welcome to stay. So this will be log, I'm going to write them as log of the same number, log 3 cube. Oopsie, sorry. I guess I was too close to the top. Let's drag this down. And you come here. So log 3 cube, log 3. Can you see that? Then this becomes 3 times log 3 divided by log 3. Now you cannot, because by saying log 9, what you did is this. Log 27 divided by log 3 is log 9. You divided this, right? Or some people could have said 9. They cancel the log, then they cancel the number. They tell you that, no, both of this is wrong. The log of a number is like saying sine 30. Can you separate them in trigonometry?
No.
It's a function, right? Aha, you can't separate. The same way you cannot separate, they are together. All you can do is to consider them together. Can you see that?
Yeah.
So cross out log 3 and log 3, you are left with what? 3 as the answer. Okay, so we're going to do the last one together now. The last one. B will be the last one we will do together.
Mr. Daniel, I have a question about C. Is that also supposed to have 0.008?
Yes, my bad. Yes. So in this case, what log do you think I can change this to?
3.
Log 3. So this will be log 3 squared, while this is log 3 to power 1 over 2. So this will be 1 over 2 log 3, while this is 2 log 3. So when they cancel, I get half divided by 2. Of course, we know half divided by 2 means half times 1 over 2, then you get 1 over 4. Did you see any link between this question and some previous questions? Okay,
So
this. 1 over 4. There's a question that gave 1 over 4. Yes, this one. Can you see any link?
is the denominator log just the base?
Yes. Can anybody tell us why? Why there's a link? Anyone? Try.
There's a rule for that.
Is it the change of base?
Change of base. That's change of base, because if I'd given you log 9 root 3 and I asked that you change it to base 10, you would have done log to base 10. Remember, we don't have to write 10 in base 10. Divided by log to base 10, and it would have been this divided by this, right? So change of base is what makes them, being written in this form. So if you get 1 over 4 here, you must get 1 over 4 here also, because they are the same. You have just written them in different forms. Does it make sense, please?
Yes.
All right.
Yes.
This is where we stop. Before I get sued by the Form 5 for being late to their class, I've taken 1 minute of their time anyway. So this is where we'll stop. I'll send you the video and the board later, and I will share this question that I'm working on. I'll share with you as soon as it's completed. So we'll meet on Monday, and like I said, from next week we'll meet 3 times now. Since we don't have business with IGCSE anymore, we focus on regular math class. All right. See you next time, everybody. Sorry for keeping you waiting if you have other things to do.
Bye-bye.
Bye-bye.
Bye.
Bye bye.